Hello? Am I audible?
Yes, audible, ma'am.
Yes.
Okay. And is my slides are visible?
Yes.
Yes, ma'am. Question is visible, ma'am.
Visible, right?
Yes, visible.
Just a minute, 1 minute. Okay. Hello? Yes. So very good afternoon, evening to all of you. I am Ashmita Das, PMRF Research Scholar from IIT Guwahati. Today I am going to discuss some problems which belongs to week 6, metallic biomaterials course, which is coming under course BT44 medical biomaterials. Okay. So here comes the first question. If a plane cuts the x, y, and z axis at 4, 8, and -2, what is the Miller indices of the plane? Anyone able to solve the question?
Hello, ma'am.
Yes.
First of
Hello?
all, take 1/4, 1/8, 1/2, and take the LCM for the three numbers. For minus symbol, the bar means bar.
Bar should be there or bar should not be there?
Bar should be there, madam.
Yes. So if we remove the bar, suppose bar is basically for the notation of the minus sign, right?
Yes, ma'am.
Yes, ma'am.
Okay. So anyone, any other answer? What is Miller indices? So can you tell me what is Miller indices?
Miller indices is
So Miller indices basically a form of a notation system.
yes, ma'am.
It basically denotes the lattice plane, and it is basically described by three integers, that is h, k, and l. These are the Miller indices. When it is given in single first bracket, it means it denotes the planes. So here, in order to denote any plane through crystal lattice, we can use a system Miller indices. It describes the crystal faces. It's defined the three indices H, K, L, N as the reciprocal cutoff with the three crystallography axes. The triplet is placed in the brackets, that is HKL, and describe a set of parallel pairs with certain relative orientation to the crystal lattice. So suppose these are the three crystal axes A, B, and C, and one plane which is cuts these three axes at three different points. Like at suppose we go for the red one. So there are 3 points. It cuts the axes, and so we can find the plane of these Miller indices by three ways. First one, we take the cutoff of the axes of the x, y, z as a multiple of a, b, and c. If the place does not intersect an axis, this is an suppose if a suppose one plane it is parallel, it cut both a and c, but does not cut the b axis like the y axis. So we can say then we take the Miller indices of k as infinity. Just a minute. Okay. So suppose this is a plane, we go for the red one. It cut the z-axis at C point, x-axis at A point, and y-axis at B point. So the here the three cutoff will be A, B, and C. Right? Now suppose it going parallel, it cut only at point A and point C, but does not cut at point B in the y-axis. So that time it will come as A alpha or infinite comma C. Okay, so I have a question. If suppose there is a plane which does not cut the z-axis at C, there is a plane which cut the x-axis at point A1 and y-axis at point B1 and which is parallel to the z-axis and does not cut the z-axis. So what will be the HKL value? What will be the HKL value? Okay, I'll give a more good idea. Wait a minute. Okay, this are three axes, right? This is x-axis, this is y-axis, and this is z-axis. Suppose there is a plane which is parallel to y-axis. It cut the z-axis at cut z-axis axis at point 3 and cut x-axis at point 2. So what will be the ABC value of if we go for this, find out the HKL part, Miller indices. So what should be there in the X? A value. What will be considered as a value? In the place of A, what can be written? As a first step to find the Miller indices. What can be written in the place of A? Did I able to make the question clear to all of you? Anyone have any doubt, please ask.
Yes, ma'am.
Okay, so in H, what should be the value we will write in the place of A in the blank space here? Z-axis is 3 and x-axis is 2. Cut the x-axis at point 2 and z-axis at point 3. So what will be written in the place of H for the calculating the HKL? The first step. There are 3 steps, right, for the calculation of the HKL value. H, K, and L. Step 1, step 2, step 3. So first step, there is a 3-axis. There is a plane. It cut the, this is X, this is Y, and this is Z. Sorry for the drawing. Here it is Z axis, it's 3, and here it's 2. Okay. So in the first step, it's supposed to be A equals to A equals to B equals to and C equals to. So for this value A, what should be the value of A? Hello?
Yes, ma'am.
Yes, what will be the value?
-4 A value.
No, for not this one. Wait.
Oh, okay, ma'am.
Not this one. I giving a question like there is one. It's a axis, 3 axis. This is x-axis. This is y-axis. This is z-axis. The plane cut x-axis at 2, z-axis at 3. So for the first step, what will consider in the place of x intercept, y intercept, and z intercept? X intercept will be like, to find the HKL value, we follow 3 steps to get the Miller indices, right? So here is,
Okay.
I am only asking about the intercept. So what will be the X intercept?
2, ma'am. Okay,
Okay,
X value
X
2.
is, yeah, the correct answer is 2. For Y,
2.
what will be the
For Y, 0.
intercept? Sorry?
0.
It will be 0 or infinite?
Infinite, ma'am.
Infinite. Because it is parallel to y-axis, so the intercept is considered as an infinite value. Like it will this plane will intersect the y-axis at infinite distance or infinite points. So the y will becomes as infinite. So what will be the z?
3.
Okay, 3. So in the next step, what we supposed to do? This is the first step. For the next step,
Reciprocal of 1/2.
so reciprocal of the x-intercept is come as 1/2, right?
2. Yes, ma'am.
So y-intercept will come as
1/infinity.
1/infinity. So what is the value of 1/infinity? What will be the value of 1/infinity?
Hello.
What will be the value of 1/infinity?
1/infinity 0.
0. So what will be the reciprocal of 3?
Ma'am.
Reciprocal of 3 will be 1/3, right?
1/3.
Okay. So what will do in the third step? We'll
LCM.
take the LCM, the
Yes.
lowest denominator, the
Least common.
lowest. So 2, 3, and I didn't consider infinity because it will not help. So for 2 and 3, it should be the value is come as 6, right? Right? 2 into multiply and 2 into 3, the value is come as 6, right?
Yes, ma'am.
Yes. So in the third step, what we'll do? 1/2 into 6. So what will the value will come?
Three.
3. So next one will be 0 into 6. So the value is come as 0. Okay. So the third one, 1/3 into 6. So the value is come as 2. So the plane is always denoted in the first bracket. So the plane value is come as 3, right? The first value is 3, right? So
Yes, ma'am.
3. Next one is 0. So next one is 0. Is 0. And third one is 2. Okay, right? So the value is come as billiard indices will be 3, 0, 2. Okay?
Yes, ma'am.
I'll give one more question. Please do it. Suppose there is a plane which cut the x. Just a minute. Suppose there is a plane which cut the x, y, and z axis. This is x axis. This is x-axis. This is y-axis. And this is z-axis. So there is a plane which cut the x-axis at point P, z-axis at point 6, and y-axis at point 2. So what will be the Miller indices? I want to hear from the step by step. So what will be the intercept first part, first step? Anyone who is comfortable with, please help me to solve it. What will be the intercept value come?
3 to 6.
3
3, 2,
to
6.
6.
What will be the second step?
3
Second step?
1 by 3,
1 by 3,
1 by 2,
1 by 2, and
1 by 6.
1 by 6. What will be the third step?
Take LCM for 3 to 6.
Okay. So then 6 the LCM then? For 3 to 6. Okay. So we'll go for LCM, like using 2. So 3, 1, P. One next step. 3, 1, 1, 1. So 6. Okay. Third step will be? Anyone? The third step?
LCM is 6.
Yeah. Yeah?
LCM is 6.
LCM is 6. Next? Huh? Actually, your voice is not clear. Can you be a bit more louder?
2, 3, 1, ma'am. Next answer.
So how can I get 2, 3, 1 from LCM 6? I want to know the step.
1 by 3 into 6.
1 by 3
into 6.
into 6.
1 by 2 into 6.
Okay. Then 1 by 2 into 6. 1
1 by
by
6
2 into 6. And 1 by 6. 6 into 6. So the value is come as 2, 3, 1. Am I correct?
Yes, ma'am.
Okay.
Correct.
Anyone have any doubt in Miller in this finding? So there is the following. The following is an easy way to find the value of HKL or the Miller indices. The x-axis index is known as H, Y, K, and L. Z-axis is L. Take the cutoff of the axis X, Y, Z in the multiple of A, B, and C. Okay. Then take the reciprocal of each number. The reciprocal of infinity is come as 0. So if the plane does not intersect, this point is very important. Please remember, if the plane does not intersect the axis, this is considered as infinity. And the reciprocal of infinity is always 0. So multiply each with the lowest common denominator to get the integer. So here it will be that minus 2, 1, minus 4. Now moving to the next question. An unit has a following dimension. It is when A is equal to 1.2, B is equal to 2.3, C is equal to 3.3, alpha equals to 80, beta equals to 95 and gamma is equal to 85. What will be the correct answer?
Triclinic. It's triclinic.
Yeah, anyone have any different answer? What is a unit cell? What is unit cell? Anyone have any answer? What is unit cell?
So is it a smallest atom in the crystal?
Unit cell is the simplest repeating unit in the crystal.
Yeah, yes.
Okay. So their opposite faces of unit cell are always parallel and the edge of the unit cell connect with the equivalent points. So if we go, the correct answer here is triclinic. So these are the some Brevis unit lattice. So the first, the cubic, the first will be the cubic. In the case of cubic, what happened? The cubic is usually differentiated into three parts, one is simple, body centered and face centered. Then comes the tetragonal, it is the simple and the body centered. Monoclinic structure, monoclinic is simple and end centered. Then comes the orthorhombic structure. Orthorhombic structure has simple, body centered, face centered, end centered. Hexagonal is the rhombohedral. Hexagonal and triclinic. These are the three different structure. So here, as you see the condition that A1 is the dimension. So the dimension is also not similar and the angle is not similar. So the unit cell here is the triclinic. The edge, here the ABC is basically denotes the edge length and these are the internal angles between these edges. So I mark it once. These are the edge length, edge length, and these are the angles. Okay. Now moving to the next question. Which statement is true? Okay, can anyone tell me in which concept this is based on? Anyone have any idea?
No idea, ma'am.
Okay. So the correct answer, the first I tell the correct answer is HCP is more plastic than FFC, which is more plastic than BCC. Okay. So there are three concepts. The first one is the slip plane. Slip plane is the plane which has the greatest atomic density in a unit cell. The slip direction is the closed pack direction within the slip plane. Slip plane is the closed pack direction in the, suppose you take consider a FCC plane, suppose in a ACC structure. So which plane has the highest atomic density? That plane is considered as a slip plane, and the direction of the atoms in that slip plane is considered as a slip direction. And the slip system contains both the slip plane and the slip direction. Now, if I move to a screen here, suppose this is a hexagonal closed pack system. Suppose. Okay. So this is a slip plane, suppose, and there are this plane is suppose 0, 0, 1 plane. Okay. And now there are three directions. First, the direction is this one, but this is the suppose this direction is 0, 0, 1. This is one direction. This is the second direction. This direction also in the sleep plane. So this direction is basically the sleep direction only. Sorry, and the notation is wrong. Okay. Okay, so one direction is 0, 1, 1. This direction is 0, 0, 1, 0, 0, 1, 0. And one more direction in this direction. This direction is 1, 1, 0. I'm not going to detail about these things. Why denotation like this? So these are the three direction. So this, so there, how many slip system will be present? If we have to make a wild guess, Any idea if we have to combine the slip system, which basically combines the slip plane and the slip direction? So how many slip system will be there here? Any idea? So suppose I will go by the picture. There are three slip system, right? The first one is 0, 1, 0. This direction, sorry. Okay. So one is this direction plus this plane. So 1, 0, 1. So 0, 0, 1. Okay. So what will be the next slip system? Anyone can help me to guess?
110.
No, I want the complete description of the complete denotation of that system. Here, as you can see, this thing as here you can mention as 0, 1, 0, 0, 0, 1. This is the complete slip system. So what will be the second slip system? So I will clear you one more time. The plane is plane is 0, 0, 1, and direction is how many direction is there as per the arrows?
3, ma'am.
3. So what will be the first direction? First one which will be suppose 0, 1, 0, right? 0, 1, 0. What will be the second direction? 1, 1, 0, right? This one. So 1, 1, 0. And third one will be 0, 0, 1. This direction I am just choosing randomly. It's not like there should be any specific. Suppose these two, these three. So this first slip system is a combination of these two. So what will be the second slip system? Second slip system will be combination of these two. This plane and this direction. So what can I written here? Anyone?
0, 0, 0, 1, 1, 1, 0.
So first it will come as 1, 1, 0, the direction. Then comes the plane 0, 0, 1. So what will be the third slip system? Anyone? The third slip system will be these three, right? This one. So the third slip system will be this one. So what will the third slip system denotation?
001 001.
Yeah, 001 001 direction and 001 plane, right? These are the three slip system. We can figure it out from the picture, as you can see. Is it clear to all? Anyone have any doubt?
Yes, ma'am.
Yeah. Anyone have any doubt? Please tell me if anyone have any doubt, please.
Yes, ma'am. Clear, ma'am.
Okay. So now if you can see this sleep system and this sleep system, if we consider these two sleep system, it can automatically we considering this sleep system, right? Because if we consider this direction and this plane and this direction and this plane, automatically can we consider this direction and this plane? It is already combined by these two, right? Isn't it? Please reply, anyone. This one, if we go for this direction, suppose you consider this direction and this plane. Okay. Suppose atoms are distributed like this direction. We consider in this direction and we consider this plane. Okay. And then we consider in this direction. So this direction and this plane. So automatically we can consider this direction also, right? We no need to put any extra effort to go for this direction and this plane. Do we?
Yes, ma'am.
Okay. Anyone is clear to all? Is clear to all? The concept of sleep plane and sleep direction. The direction basically the density of the atoms in a which direction. So if we have find out this direction, the density will be more, and this direction the density will be more, and this is the plane of the density of the material. So there is no point of going for this direction density, right? It already covered by this direction and this direction. Am I make it clear?
Yes, ma'am.
Okay, so for that, this is the like ideal case of hexagonal packed system, hexagonal cubic packed system. So because of that, HCP usually contains two sleep system. So HCP basically has three sleep systems, but among them two are predominant. One plane, three direction, so three systems. We know that minimum 5 independent sleep systems are necessary to make a polycrystalline material ductile. So HCP is basically brittle. Okay. So this is a like thumb rule for there. You have to have minimum 5 independent sleep systems to make any material ductile. For the HCP, there are three sleep systems and two are independent and one is dependent. So we can say HCP is a non-ductile material. It's a brittle material. Now moving to the FCC. FCC has 12 slip system. So 1 family of planes and 1 family of direction. So 3 into 4, like 3 1 plane and 4 direction. Suppose 3 plane of 1 and 4 direction. If we consider total number of slip system, it's 12. So understood why 12 slip system comes? Suppose three planes A, B, C and 4 direction X, Y, sorry, W, X, Y, Z. So how many sleep system will be formed? Please tell me quickly. The first one will be
AW,
yeah AW. Second one
AX, AX,
AX,
AY, AZ.
AY, AY, AZ. Anyone else can me tell the second set? Anyone else? Please try to do it. Please reply. Anyone else? Hello? Hello, your voice is not clear. Please, can you a bit louder?
BW,
Yeah. B,
W,
B,
W,
BW, then
BX,
BX, then
BY,
BY,
BZ.
BZ. Okay. Anyone else? The third set?
CW, CX,
CW, CX, CY, CZ.
Z.
So how many slip system will be formed? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Clear?
Yes, ma'am, clear.
Okay. So FCC 12 slip system, 3 families, 3 family of planes and 4 family of direction. So 12 slip systems, which is more than 12. Which is more than 5, right? So FCC is a ductile material. Now going to the BCC. BCC has 48 slip system and expecting better ductile, but it is brittle. Why? It has 6 family of planes, 2 family of direction, So total 12 slip system plus 6 different family of planes and 2 direction. So again, how much? 12 systems. Then again 6 family of planes, 4 family of direction, 24 slip system. So the grand total will be how much? 12 plus 12 plus 24. So what much it come? It will come as 48. But BCC lattice structure has too much slip system. The slip system interfere or mutually obstruct each other. Therefore, the slip movement is BCC very, very difficult, and therefore this material is a brittle material. So HCP is more plastic than FCC, which is more plastic than BCC. Just a minute. Sorry. Very sorry. The correct answer is, so the correct answer is this one, not that one. The correct answer is this one. HCP is less plastic than BCC, which is less plastic than FCC. Okay. Sorry. So the less plastic one is comes as BCC, right? Then comes HCP. Then comes FCC. So FCC is less. So FCC is less plastic than HCP. HCP is less plastic than FCC, right? Which is less plastic than less plastic HCP. This one is correct only. The HCP is less plastic than BCC, which is less plastic than FCC. Okay. Now moving to the next question. Alpha aluminium forms a cubic pack structure, so it has a coordination number of anyone? Anyone?
12, ma'am.
Sorry?
12. 1, 2.
Yes. In a cubic closed pack structure, there are 3 different layers. First layer is as same as the fourth layer. First layer, second, third, fourth. Similar as the fourth layer, it is of the type ABC. So ABC, ABC. The first layer has 6 atoms. This layer has 6 atoms. 1, 2, 3, 4, 5, 6. 6 atoms. The layer on the top of it has 3 atoms, and the third layer is also has 3 atoms. So for a cubic closed pack structure, each atom is touching 12 other atoms. The coordination number of CCP structure is 12. Okay. Now moving to the next question. Graphite has lower coordination number than diamond because Anyone? The correct answer is the former forms the 2D layer. The correct answer is, sorry for the inconvenience. This red button has shift in every place. So the correct answer is this one. The former has 2D layer. What happened? This is the lattice structure of diamond and this is the lattice structure of graphene. In graphene, each carbon has 3 nearest carbon. If we see that more detail, each carbon has 3 nearest carbon atom. One is double bonded with one is attached to the double bonded with the other atom and two are attached in a, suppose we consider this one. So it at one side attached in a single atom, double bonded to one atom, and another side it is single bonded to other atom and single bonded to other. So basically three neighboring at nearest atoms is there. But what is in the case of diamond, the tetrahedral bond is formed. So suppose we go for this C, it is has one nearest atom, two nearest atom, three nearest atom, and four nearest atom. So four single bonds in each C atom. So because of that, the coordination number of diamond is more and the graphite is less because it forms the 2D layer. Iron exhibit BCC structure at room temperature above 900 degree transform to FCC structure. The ratio of density at room temperature at 900 degree. Let's solve this one. Anyone? Okay. So there are two relations. This is the relation which defines the atom radius and edge length. Here A is the edge length. Edge length. Okay, so I better go for this one. So for BCC, suppose this is a cube. and this is a cube. So there are 1 atoms okay. So there are two diagonals for any cubic system. One is the face diagonal and one is the body diagonal. So face diagonal is like this diagonal. This is the face diagonal. So face diagonal is basically denotes by a square plus a square. Okay. And body diagonal is denoted by FD. Body diagonal basically this diagonal from top to bottom is basically contain FT plus a square. कौन? हाँ पता नहीं होगा मैं भी लैपटॉप है तो क्या करूँ मतलब ब्लॉक कर दूँ या फिर रहने दो हाँ हाँ बाय बाय हाँ तो FT plus a square. So what will be the then the values come as so what will be the body diagonal value with respect to A. So we can write here a square plus a square plus a square. So it comes as 3a square. It is clear to all why this a square comes.
Yes, ma'am. It's a face diagonal value a square plus a square.
Okay. So in the body diagonal case, what happened? The atoms along the body diagonal and touches each other. So, it has the radius is 4 times. The body diagonal has the body diagonal length is the 4 times of the radius of the atoms. So basically, BD equals to 4R. So it can be also written as what? This relationship can also be denoted as a Pythagorean equation. So basically 4R whole square equals to 3 a square. So from here can be also written as 4r equals to root 3a. So from there, this equation is coming. 4r equals to root 3a. For FCC, it comes as 4r equals to root 2a. So from there, we can found the edge length a equals to 4r divided by root 3 and 4r divided by root 2. This part is clear to all. Excuse me. This class is clear to all. Please reply.
Yes, ma'am.
Okay. So now from 4r root 3 and 4r root 2, if we go for density, this is the formula of density where it is this is the formula of density, and there we put in the place of edge length, we put directly 4r by root 3 whole cube and 4r by root 2 whole cube, and the rest of the things will cut off, and the value is come as 3 by 4 root over 3 by 2. Now moving to the next question. The atomic packing factor of iron increases by what fraction when it's cooled down from 1000 degree to 900 degree? Anyone? Anyone? Okay. So the atomic packing factor of APF of iron for FCC is 0.68 and BCC is 0.48. This is a standard value. There is nothing very like you have to memorize this one to solve such questions, or it will be provided in your question paper. So the increase factor is directly 0.68 minus 0.48 divided by 0.68. This is come as 0.29. Now moving to the next question. Polyvinyl alcohol is a polymer.
Synthetic polymer, ma'am.
Yes. The correct answer is synthetic polymer. PV is basically an artificial polymer that had been used during the first half of the 20th century worldwide. Now moving to the next question. Which polymer will have oxygen present in it? Yeah. Yes. What will be the correct answer?
I think PV.
Yeah, the correct answer is PVA. Okay. So the 10th question, the PE of molecular weight is equal to PE molecular weight is 4 into 9 10 to the power 5 gram per mole. Has the repeat unit CH2. Calculate the number of repeat unit. This is a very easy question. Please try to solve it. I'll give you 5 minutes time, 5 to 10 minutes. Please try to solve it. It's a very easy question. Okay. Anyone able to solve this question?
Hello, ma'am.
Yes.
Actually, the polymer, I have to find the degree of polymerization, ma'am.
Sorry.
The general formula is molecular weight of the formula.
The polyethylene P is the polyethylene and its repeat unit is CH2. Simple CH2. Nothing else. The repeat unit is given itself, right? Okay. So the simple formula is this one. The formula is molecular weight of the polymer equals to dP. dP means the number of repeat unit into the molecular weight of the repeat unit. The simple mass balance, nothing more. So molecular of the repeat unit, here the repeat unit is CH2. Okay. So the molecular weight of the carbon is, anyone?
Well,
Anyone? Yeah, the molecular weight of carbon is 12 and the molecular weight of hydrogen,
Two.
molecular weight of hydrogen 1.
one.
So 2 into 1, which is coming as 14. Okay? Understood? So total number of repeat unit, so MW polymer equals to N into MW R U. So N equals to come MW polymer divided by MW repeat unit. So it comes as 4.9 into 10 to the power 5 divided by 14. So the value is comes as 35,000. Okay, clear to all?
Yes, ma'am.
Okay, so anyone have any doubt about today's session? Okay, so anyone have any doubt? Okay, regarding the book, I will try to find out some of the book by this weekend or by this end of this week. So I'll post that book name in the Teams in the chat box. Please check from there. Okay.
Okay, ma'am.
Okay. So anyone has any question? Anyone have any question? Okay,
Ma'am,
then yes.
PPT link where we can get this PPT, ma'am.
PPT is actually given. I send you the YouTube channel, right? You can find the PPT from there itself. Like the whole recording for today's class will be uploaded there. You directly check from there. There.
Okay, ma'am.
And I guess they will share the PPT with you in PTL by some time because they are asking for the PPT and they are not allowing us to share any PPT. So you better check in that YouTube channel. You find the full PPT in there. Okay?
Okay.
Okay. Anyone have any question? Okay. So I am going to end today's session. Thank you, everyone.
Thank you, ma'am.